Yeah.
Hi everyone. Today we are going to have a session about Gradle, and the topics we are going to cover in the session about Gradle, Gradle wrapper, plugins, repository, managing dependencies of Gradle, projects and tasks, executing multiple and advantages of Gradle. And Gradle is a build system and it's an open source which is used to automate building and testing deployment task related jobs. Here we are using build.gradle. We are using build.gradle file which can be written, which file is used to write a build script. In this file we can automate our task. For example, copying a file from one destination to another. These tasks can be these types of tasks can be automated using Gradle. And Gradle is not using any XML related formats like Maven or Ant. It's using domain specific languages based on Groovy or Kotlin. And Gradle builds tend to be much shorter and clearer than Ant or Maven. Like for example, if you are Gradle achieves some task in 100 lines, the same task can be achieved using Gradle less than 20 lines of code. Initially, Gradle used Apache IOI for its dependency management. Now, later on, it is using its own native dependency resolution engine, which means it is having the support for dependency management. It is a sample format for Gradle template. This is where we use to apply the plugins, and here we can specify the formats of the project version numbers and repositories, dependencies, jars, Java distributions. This is a simple format of the Gradle. Let us see in detail in the coming slides. Here, Gradle recommends us to use wrapper. For example, if one develops a project, if we are distributing the project with other developers, and other developers, they no need to install the Gradle in their system using the manual, downloading the Gradle and installation. These steps are something like it will time taking things. So to avoid this, we can use Gradle wrapper. So when we distribute the project, it will download the wrapper from the internet and it will make use of the Gradle wrapper. Using this Gradle W command, we can use the Gradle wrapper. And plugins, what into a project, means it's supposed to extend the project capability. Like ability to compile the Java code, and even we can use our own plugins, which we can develop and we can make use of it through the plugins. Like here we are using the Spring Boot framework plugin.
So, Arukraj, one question for Gradle, as a prerequisite for Gradle to run, what needs to be installed?
Gradle.
In addition to Gradle, like what are the prerequisite for installing, like for running Gradle? Anything else is required other than Gradle?
It depends on the project. If you are going to use Java,
no, as a prerequisite for Gradle, yeah. So Java Gradle.
Yeah, Java, yeah, Java Gradle needs.
Okay. And any version of Java which is pardon?
It is not specific to Java version. It can be any version.
I think the latest Gradle requires at least 8 version. Minimum 8 is the for Gradle. Pardon?
Tested supporting between lower version and higher version. Currently, I'm using JDK 8, so I didn't see any. We need to go to the topic.
Yeah, please
Supporting
continue.
Yeah. And it next we are going to speak about declaring the repositories. In our project, we can use dependencies like MySQL libraries and log.
Anybody hearing properly? Like I could not hear.
Yeah.
Hello.
There's a
Is it
break
problem?
in.
I think it's a problem. Yeah.
Internet connection is
Okay. Okay. Yeah. Continue.
Is it better now?
Yeah, it's better now.
Yeah. Yeah. Here, Gradle repositories can resolve dependencies from Maven or IVY and JCenter repositories. We can resolve our dependencies. Like here, we are using like a Gradle build can resolve dependencies from Maven Central, WinTray, JCenter, and Google Android. These things can be resolved. Even our local repositories can be configured with Gradle to resolve the dependencies and manage dependencies. We need to use the element this build.gradle file to define our project dependencies. When we define a dependencies like this, it will here we have defined our repository like this, right? Whatever the location repository we provide over here, these dependencies will be resolved from that repository. And this is the, there are two ways we can use. One is API, another one is implementation. Java will support implementation, and Java library will support ABA as well as implementation. The difference between both is 1 minute.
Hello.
ABA as well as implement.
Yeah. No, there was a break in between. Yeah.
ABA
Continue.
as well as implement. We can use ABA as well as implementation. If you are using Java library plugin imported, that will support ABA as well as implementation. If you are importing Java plugin, that will support only implementation. The difference between ABA and implementation is implementation will not expose the internal libraries to consumers, but whereas implementation will not expose the internal libraries to consumers. That's
So
a major
you
difference
mentioned two
between
things,
ABA
right?
and
Java and
yeah,
Java plugin and Java library plugin.
yeah.
So what is the difference
Java will
between these
support
two?
only when we are using Java, that time that we can use only implementation. Implementation group is there, right? These are all common things. Group name, this can be common. And here we can use implementation or API. API will expose internal libraries, which are, for example, this when we are defining log4j, that will download 3 jars. We might have seen that one. That will resolve 3 jars. Only one defined by us, and another 2 are internally depends on one another, which means transitive dependencies will be there. So that internal uh, that internal library should not be exposed to the consumer means, then we have to go with the implementation approach. I can show that.
Yeah, yeah. I understood. We mentioned implementation and the API approach. My doubt was you mentioned in the case of Java, we go with implementation, and if and we
Yeah,
go Java library plugin, we go for API,
yeah,
right?
yeah, API as well as implementation. It
Yeah.
supports both.
So what is these two, like Java plugin and Java API library plugin? What is these two difference? What are these two?
Yeah, when we go with Java, that will support implementation only, but Java library supports the both API as well as implementation. API
So
will
Java library
expose.
means how it is different from Java. I'm trying to understand. You're saying Java supports this, Java library supports this. So what is this
Yeah,
difference? What is Java library and what is Java? Like how can I
uh,
have Java library in my machine?
yeah, Java plugin will not expose internal library to consumers, but Java library will expose
So
internal
basically
libraries to
what you're saying is Gradle has two plugins. One is Java
yeah,
plugin and one is Java library plugin.
yeah,
So these are two different plugins provided by Gradle.
yeah, correct.
Yeah, that's what. Yeah, because the terms are confusing, like Java plugin and Java library plugin. We need to tell what is this difference. Yeah, please
Actually,
continue.
Hello,
yeah,
uh, hello, Arigraj.
yeah.
Java library plugin is there. What is that API?
Yeah, that's a keyword which can be used to resolve dependencies. Both API and implementations are used to resolve the dependencies, but the major difference is API will expose the internal libraries to the consumer, but implementation will not expose the internal library to consumer. That is
So
the
you mean to
difference.
say, suppose if 3 jars are there, so
Yeah.
only it will be bundled as a 1 jar. The remaining 2 jars, which depending on that, I can't see that.
Yeah, correct. For example,
Oh, okay.
MySQL only we have defined over there, but MySQL, for example, just for example, I'm telling, if MySQL resolve two libraries, one is MySQL library, but it is uses some feature from another library. That is also will be resolved to our project. So that project libraries will be resolved over here. So both two will be both two can be used in our project if we are using the
Okay.
API. Okay, but when we are using the implementation, we can use only MySQL features, but not that another library which is used by MySQL.
Okay,
If we are
okay. If you
going with
use
the API approach.
implementation, the remaining two things cannot be used. If you use
Yeah,
API, all the features can be used.
yeah, no,
Yeah, okay,
exactly.
okay. Yeah, yeah. I got it. I
But we
got it.
should not do that one. Actually, we may use the latest version of that another library which is used by MySQL. That may meet some conflicts, and if we are falling in some requirement, in that time we can use API approach.
Yeah, okay, okay. I got it. I got it.
Yeah.
Arigraj.
This is yeah.
Yeah, I have one doubt. See, I have not used apply plugin Java or Java library, but still I can use implementation group inside dependencies element, right? Because I'm
Yeah,
using like that only.
yeah, we can.
Then which will be used?
But
Apply plugin Java or apply plugin Java group default? Which is default?
like I didn't get you. Can you come again?
Yeah, I have not
But
used apply plugin Java or apply plugin Java library. Okay,
in that case, that will by default it will use Java only, but it will not
apply
support
plugin
API.
Java.
Yeah, yeah.
Oh,
Java
apply
library
plugin
will not
Java
be.
is default one, right?
Yeah.
Okay, okay. Yeah, thanks.
And declaring dependencies. Every dependency declared for a Gradle project applies to a specific scope. And for example, some dependency should be used for compiling the source code, whereas others only need to be available at runtime. Gradle represents the scope of the dependencies with the help of configuration. uh, every configuration can be identified unit name. Like here, this can be used at a compile time, and runtime only. This can be used in only runtime time. So Gradle supports each and every keyword has its own scope. That is what Gradle dependencies. And it's image of the how the dependencies are resolved from repository to local machine. And Gradle uses the catch mechanism, so the building time will be faster comparing with Maven. Here, Maven and IUI repositories are configured, and this cache can be used if it is already available. Some dependencies it will be reused. It will not resolve the dependencies again and again. So the build time will be faster comparing with the Maven. And build script basics. Everything in Gradle sits on top of two basics: projects and tasks. Every Gradle build is made up of one or more projects. What project represents depends on what it is. It is that you are going to do with Gradle. For example, here we have a task and hello and intro, and here we are using the depends on hello. So which means we can this intro depends on hello, like that. It's some simple example for basics of build script. And projects and tasks. Here we are having some examples for Gradle tasks, that is jar, copy, zip, test, and Java talk. We shall see that in detail. Jar task. Actually. It will archive the project source into jar file. Here we can use the manifest attribute and archive base name. This thing can be configured over here, and using the attributes keyword, we can configure the class path for the jar if we want to make it runnable. And main class, these kind of attributes can be configured over here, and that's it. Copy task. Copy task will copy some sources from origin to destination. That can be configured over here. Into and from keywords are used. Where to where we have used. Here we are copying that file from configuration.runtime class path to this libs folder. So here we can use include or exclude keyword based on our requirement. Then whatever apart from these files, everything will be copied from origin to destination. Zip task. Zip task will compress the files and it will make these folders as we mentioned over here. It will create one root folder PMS, and inside that everything will be copied over here. From which folder it needs to be copied and where it needs to be pasted. Like that we can specify over here, and here we can specify the zip name using archive base name and destination directory to which location it needs to be copied, and same thing will be followed for all the things. Test task. Test task will resolve, will detect the test cases automatically in the Gradle using this test block. Either if you are going with JUnit approach or test engine approach, based on that we need to design our script so that when we are running the script, by default that test cases will be identified and executed when we are running the Gradle test task. During the build time also it will be identified and it will be executed by default. If we want to skip the test cases, right, we can use Gradle -x test command to skip the test cases. Java commands used to generate a HTML API accommodation for Java classes. Here we can same thing like include or exclude keyword can be used and title can be configured. All the things we can perform. Apart from these classes, Java will be generated based on the annotation and information provided in the Java library, Java classes, so that it will be generated in the form of HTML API documentation. And depends on and must run. Depends on must run task will combined together will define a order of the execution and like this. For we have made clean directory, payroll directory. We have defined different sets of tasks. Right? We can order using must run and depends on task. For example, we can make a main task which is depends on these all the tasks like clean directory, payroll, test, whatever the things we are going to use. We can make it depend on this task so that and the task can be identified using that name, task.find by name and payroll jar, and this task should be run after clean directory, like that we can specify over there, and so that it will be executed in this way of approach, so that we will have a sequential order to avoid any missings of tasks. And executing multi-projects build. A multi-project built in Gradle consists of one root project and one or more sub-projects that may also have sub-projects. For example, we are using one main projects, right? Project A depends on project B, means we may use some libraries for main projects. For that, we no need to make a jar of it and we have to apply it. Directly we can make that project depends on this main project like this. In dependencies, we can specify like this: implementation project, this sub-project name, that is that's in sub-project, that settings Gradle should be configured with this name, SMS, so that it will be resolved from after this after resolving this projects, it will be executed, which means this main project is depends on SMS lib. In this way, we can achieve that multi-project execution in our project. Advantages of Gradle. Gradle provides highly customizable performance and flexible user experience and general purpose. Highly customizable means Gradle is it can be customized to different projects and different technologies. It can be customized in many ways, like it can be used in Java project, Android project, Ruby projects. So that in different technologies, it can be customized. And performance means it is very fast in performance. It is about 2 times faster than Maven in all scenarios, and 100 times faster in large builds using build catch. It is using a catch mechanism, so it is much faster comparing with Maven. Flexibility. Gradle is flexible tool. Gradle is a plugin based build tool. We can create our own plugin in different programming languages like Java, Ruby, Kotlin. If we want those plugins, we can apply it in our project. We can make use of it. User experience. Gradle supports wide range of IDE to provide an improved user interface. Most people prefer to work on IDE, but many people prefer to work on terminal. Gradle provides a command line interface for them, and Gradle command line interface offers many powerful features like Gradle task. Like we can design our task, and using that those tasks can be executed using command line. It also provides interactive web-based UI for debugging and optimizing builds. And general purpose building tool. Gradle is a general purpose build tool. It allows us to build any type of software. Using this Gradle, we can build any Windows application, web application, console application, any types of application we can use. That's it. Any doubts? Hello.
Yeah. So any questions from anyone? This is the time.
Yeah. I think, is there a time for questions right now, or we can continue?
Yeah, please continue, Yogesh.
Yeah, basically, I was just going through that Gradle page. There is something called Java platform plugin also. So what is the meaning of that platform? When would we use Java platform plugin? If you can open that.
I think it is introduced in.
Yeah, sorry.
I have not tried the Java platform plugin.
Okay.
I think it's newly introduced approach, I guess. Sorry.
Yeah, this link I have shared, you can go through this Java
Yeah.
platform plugin.
Yeah, we should know when to use that. I mean,
Okay. It's a combination of Java or Java library plugin. Yeah, anyway, I shall try it out and I shall share the details with you.
sure. So you know this our TrueView product, right? It has multiple components. So somewhere we might use Java library plugin, or somewhere Java application plugin, or somewhere. So you need to understand when we should use which plugin.
Yeah, sure.
Another thing is, does Gradle have any, it supports deployment also, right? So deployment on cloud platforms and all also it supports?
Yeah, it supports. I have tried with just I have tried deploying a jar in a Nexus repository in cloud using.
So does it have an integration
Yeah.
with Docker or something?
Yeah, it supports, but we need to try it out, deployment and all.
Okay, sure.
Yeah.
Yeah, thanks. That's all I have.
Yeah, sure.
Argraj, one doubt. I didn't understand Gradle W correctly. That command you are telling about in the initial slides, right? So
Yeah.
if we use Gradle W, if I don't have Gradle install in my system also, it will only install and set it right.
Yeah, for example, I have created a project and I'm giving the project to you. Then you no need to
Okay.
install the Gradle in your system, then you need to continue. Directly you can use Gradle W command, then you can make use of the software. But when we are making the project, that time we should have the Gradle installed in our system. When we are distributing that project with some other developer, then we no need to install the Gradle, downloading it. Using the Gradle wrapper, automatically it will be used.
Yeah.
Yeah.
Okay.
So you like during development you require Gradle, but once the project is available while execution of the project, you can use Gradle W, right?
Yeah, correct.
Anyone else has any questions?
Yeah, Aragresh Vishnu here.
Yeah.
So to use this Gradle W, right? Do we need to have any other things in our while we, I mean, building this Gradle script? I mean, do we need to add something in our project to, I mean, to be executable with Gradle W?
If unless the project requires any prerequisite things, we no need that one. For example, JDK alone is enough to build this project. If you are going with the Gradle W approach.
Okay. I think if anyone else, any questions? Okay, then I will pause the recording.